Hi there, this is Ayush, and I'm gonna talk about this agentic tool we are building at Lightscline, which can be used to analyze any kind of sensor data. I'm gonna show an example on distributed acoustic sensing data, uh, but you can use it for anything like weather, vibration, sound, any kind of sensor data. So, uh, let's start with Forge data. So, Forge is a very famous dataset in DAS, but uh, I'm gonna tell it to plot the data for Forge for a specific time period. I know that this time period has a microseismic event in it from the catalog. So the goal is, can I figure out what kind of processing is required to actually see that microseismic event? Now, this query, can you plot the microseismic data on a specific time, is very generic. So it asks me like, what kind of plot do you want? I'm gonna say time heat map, because that's what I want to see. But the goal is, it doesn't assume that I want a spectrogram or an FFT or something like that. Instead of assuming, it's gonna ask the user, can you be a little bit more specific and tell me what I want? This is what we want from a system. This way we'll be sure that whenever it's unsure, it just asks the user itself. Now here, if you see, some channels here are very noisy. So you know what we are gonna do? Let's just take like a channel 200 to 1000. So I'm gonna ask it, I see some channels are noisy. Plot time heat map for channels 200 to 1000 only. So basically, I'm gonna ignore these noisy channels for now and then focus on one part of the graph. It's kind of zooming in into that. So okay, there was supposed to be a microseismic event, but I'm not able to see it. So let me just ask it. There was supposed to be a microseismic event here. Can you tell me why I'm not able to see it and what kind of processing might be required to see it? So, because I don't know what to do next, the goal is I can just ask an LLM, which is like, which will give me something which I can work with. So, this is still in beta, and sometimes you get. So, it was trying to compare Force dataset with the GeoSense dataset, which is present in one of our data connectors. So one of the things you can do is you can actually compare whatever data you have and then overlay plots and stuff like that. But yeah, because it's in a beta release, you might just give the same query again and it's going to give you an answer. Anyway, so uh, I'm going to look at what are the recommended processing includes. So channel QC, we already kind of did a channel QC because all channels looks fine. Detrending, we can do detrending, but I think let's go with bandpass filtering to start with. So I'm gonna ask it, what bandpass filter frequency range do you expect for microseismic events in Forge? Because I don't know, as a new user, I wouldn't know what kind of microseismic events is expected, like what kind of filtering range is expected for a microseismic event. Now it says you should try something like 10 to 200 hertz, and then it also gives me more steps to do it, but I'm just gonna try bandpass for now. Show the bandpass time heat map plot of the data for 10 to 200 hertz. So I'm just gonna like follow this, like whatever it says, and I'm able to see this event now. So that's the good part of it. But the next step is gonna be, I actually want to see the code it generates, because yes, it shows me microseismic event, but to be like 110% sure it's doing exactly what I want, I'm going to look at the code. So I'm going to click on generated code, and this currently this uses Lightscline internal libraries and stuff like that. But you can see that the code looks perfectly fine. It reads the data, it selects the channels that we wanted, it selects the time period that we wanted, it gets the like loads the data, filters the data and plots it, and then saves it into a file. So ideally I can just copy this code in a Jupyter notebook or a Python file and this would work. That's that's one case study for this tool for now. Thank you. Let us know if you have any questions or if you want more features. Just let me know. Thank you.